Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. InsyaAllah. Okay, today we are going to discuss one rule. So let's say given limitation of function f(x) to function g(x) when x approach a, where given also that f(x) and g(x) are differentiable, and the limitations of function f(x) when x approach a is equal to 0, and the limitation of function g(x) when x approach a is also equal to 0. So it caused that the limitation of f(x) to g(x) when x approach a equal to 0 to 0. So then this limitation is indeterminate. Luckily, we have one rule which is known as L'Hopital rules. So we can find this limitation by using the relation limitation of f(x) to g(x) when x approach a is equal to limitation of first derivative of x of f to the first derivative of g when x approach a. Let me take a look at one example here. So the question is evaluate limitation of 2 plus x squared minus 2 cos x to e to the power of x plus e to the power of negative x minus 2 cos x. So let we sub the value of x equal to 0 into the limitation. Then we have 2 plus 0 squared minus 2 cos 0 over e to the power of 0 plus e to the power of negative 0 minus 2 cos 0. Since cos 0 is equal to 1, therefore we have numerator 2 plus 0 minus 2 multiply 1, and the denominator is 1 plus 1 minus 2 multiply 1. So it is equal to 0 to 0. So this limit is indeterminate. So then we need to apply the L'Hopital rules. So we do our assumption that the numerator is become our function of f(x). So therefore f(x) is equal to 2 plus x squared minus 2 cos x. So since in the expression of f(x) here we have the trigonometric term which is cos x, then let we take a look at the formula. When we differentiate cos f(x) with respect to x, we will have negative first derivative of f multiply with sine f(x). Then we apply this concept in our numerator in order to find the first derivative of f(x). So therefore, the first derivative of f is equal to, when we differentiate x squared with respect to x, we will have 2x. Then when we differentiate negative 2 cos x, we have, so then we differentiate cos, we will get negative for sure. So it is negative sine x. So first derivative of f is equal to 2x minus 2 in the bracket, we have negative sine x. So when we simplify this function, the first derivative of f is equal to 2x plus 2 sine x. Now, let we assume our denominator is a function of g. Therefore, gx is equal to e to the power of x plus e to the power of negative x minus 2 cos x. So let we recall what is happened when we differentiate the exponential function. So when we differentiate the e to the power of fx with respect to x, it will equal to the first derivative of f multiplied with the e to the power of fx. So when we differentiate g with respect to when we differentiate g with respect to x, so we will have ex minus e to the power of negative x. Why we got negative e to the power of negative x? Because when we differentiate the power of e, which is negative x, with respect to x, we will have negative 1. So negative 1 multiplied with plus, we will get negative e to the power of negative x. Then negative 2. So then we recall when we differentiate cos x, we will have negative. Negative what is negative? Negative sine x. So therefore, the first derivative of g is equal to e to the power of x minus e to the power of negative x, negative 2 in the bracket, negative sine x. So when we simplify, we will have e to the power of x minus e to the power of negative x plus 2 sine x. Therefore, now limitation of 2 plus x squared minus 2 cos x over e to the power of x plus e to the power of negative x minus 2 cos x when x approach 0 is equal to limitation of 2x plus 2 sine x to e to the power of x minus e to the power of negative x plus 2 sine x when x approach 0. Let we sub the value of x equal to 0 into the limitation. So we will have numerator is equal to 2 multiplied with 0 plus 2 sine 0 over e to the power of 0 minus e to the power of negative 0 plus 2 sine 0. Therefore, since we know that sine 0 is equal to 0, so we will have the answer numerator is equal to 0 plus 0 and the denominator is 1 minus 1 plus 0. Again, the answer is 0 to 0, which it cause this is indeterminate. The limit is indeterminate. So meaning that we need to apply L'Hopital rule for the second time. So let me take a look at our numerator. Then we need to differentiate the numerator and denominator again with respect to x. So since the numerator, both the numerator and denominator have the term involving triangle which is sine x, so we must recall that when we differentiate sine fx, we will have first derivative of f multiplied with cosine fx. So therefore, when we differentiate the first, the numerator of the term 2x plus sine x over ex minus e to the power of negative x plus 2 sine x, this limitation, we differentiate it with respect to x, we will have the numerator become 2 plus 2 cos x. Because when we differentiate 2x, we will have 2. When we differentiate 2 sine x, we will have 2 cos x. And the denominator will become e to the power of x plus e to the power of negative x plus 2 cosine x. Since when we differentiate ex, we will have e to the power of x. When we differentiate negative e to the power of negative x, since when we differentiate the power of negative x, the power which is negative x with respect to x, we will have negative 1. So multiply with the coefficient of negative 1, then negative 1 multiply with negative 1, we will have positive e to the power of negative x. So when we differentiate positive 2 sine x, we will have positive 2 cosine x. So by substitute the value of x equal to 0 into the limitation, then the numerator we will have 2 plus 2 multiplied with 1, because cos 1 is equal cos 0 is equal to 1, and the denominator is equal to 1 plus 1 plus 2 times 1. So then we have the limitation is equal to 4 to 4, and we simplify, it is equal to 1. Therefore, the limitation of 2 plus x squared minus 2 cos x to e to the power of x plus e to the power of negative x minus 2 cosine x when x approach 0 is equal to 1. Okay, that's all for now. Until we meet again.